Okay, so thanks for the invitation and hello everybody. This talk is about Angular and it's about micro front-ends, micro apps in combination with Angular elements. So who am I? I am Manfred, I'm a trainer and consultant for Angular. I'm doing a lot of in-house consultancy and in-house workshops, and sometimes I'm doing public workshops. And my main topic, of course, is Angular. And I have also been announced as a Google Developer Expert, which means that I have a direct connection to the product team over there in the USA. My current product is also about Angular. It's an Angular workshop with advanced topics for enterprise development, for big applications that have to be maintained for 10 years or 15 years, perhaps also 20 years. And today I want to start with a picture. Who knows this machine? Yeah, some of you, very nice. This is a Commodore 64, the hero of my childhood. It was published in 1982 and it has about 1 megahertz, so it is not the fastest machine on this planet. It has 64 kilobytes of random access memory, which is also not much, and it has disks with about 170 kilobytes. And when you wanted to have a dual-core version of it, it looked like this. You had to buy 2 versions of them. Some people did that. Perhaps they used one for programming and the other one for debugging purposes. So, what do you think? What was the biggest challenge back then in 1982? Yeah, of course, the resources. The resources was the biggest challenge. You had to find enough to do with just 64 kilobytes of RAM and with just 1 megahertz. And today everything is a lot of different. Today the biggest challenge is the complexity of applications. Resources are not the problem anymore. We have some gigahertz and we have some gigabytes of RAM and so on and so forth, so that isn't an issue, but complexity is really the thing we have to deal about. And this is because our applications become bigger and bigger and more people are involved in software development. Another big challenge today is the coordination of teams as well as the coordination between teams. A big application is normally developed by several teams, and that means you have to coordinate them, and this also means you have a lot of discussions, perhaps political discussions, but also technical discussions, and of course that takes a lot of time. And another challenge is we need somehow to achieve a piece of software that can be maintained for long term. A typical business software needs to get maintained and extended for 10 till 20 years. A lot of my customers have applications that last for 20 years or even 15 years or something like this. And this is very hard nowadays because the technology is changing on a regular basis. Perhaps you know this saying, a guy said some time ago that there are milk products out there that are lasting longer than some JavaScript framework, and somehow that's true. So at the last workshop I did, someone said to the other guy, hey, what you are doing there is so much 2016. 2016, I mean, the technology was just 2 years old and he was pointed at him because of this choice of technology. And these issues is what this talk is about. In this talk I will introduce micro apps as one remedy for all those issues we have nowadays. And I will also show you how to implement micro apps by means of web components. In addition to that, I will talk about an implementation with Angular. For this I will use Angular elements, and I have also prepared a demonstration that is using all the concepts I'm talking about here. So let's get started with micro apps. The basic idea of micro apps is really simple. The basic idea is that we don't write a big system that we have to maintain for 10 or 20 years. Instead of this, we write several tiny systems. And some people are calling them microservices nowadays. Tiny applications, tiny self-contained systems that do just one thing, but this thing they will do very good. And of course they need some interfaces to talk to other parts of the overall system, to other microservices. In the back end, most people speak about microservices. In the front end, you could talk about micro apps or micro front ends. And of course, this architectural decision brings a lot of the advantages, but also a lot of disadvantages. Let me have a look to the advantages. One advantage is you can have a separate deployment. That means when you are done with your task, you can just publish your micro app. You don't have to wait until your colleague has also done his job or until another team has done its job. The other team will have its own micro app, and so you can publish everything when you are done. That's one big advantage that brings a lot of agility. Another advantage is you can mix and match technologies. Not because you want, but perhaps because you need. Remember, we need to maintain our applications for 10 or 20 years. It is a lot of time. And during this time period, a lot of new technologies can show up. No one knows which technologies we will have in, let's say, 7 years. And you don't want to stick with your technology decision from today for the next 20 years. Perhaps in 7 years you can use another framework or a whole other technology stack like WebAssembly or something else. And in addition to that, not each and every problem can be solved with each and every technology. For different problems, there are different technologies that can handle it. You need less coordination. At least you don't need a coordination between teams, because each team has a micro application of its own. That also brings a lot of agility, and it prevents those politically motivated discussions. I think you know them all. And at the end of the day, you also have less complexity, because you don't have a big overall application. Instead of this, you have some tinier applications that are less complex, of course. Of course, there are also disadvantages, and one disadvantage here is you are ending up with a highly distributed system. A system that consists of a lot of micro apps, and those micro apps are talking to each other by the means of interfaces, by the means of, let's say, REST services or something like this. Another disadvantage is you will end up with distributed data, because each and every micro app has its database of its own. And somehow you have to deal with UI composition. UI composition means that you have to present all your micro apps as some common app to your consumers. Having micro apps is a good thing for you. Splitting down your whole application into 70 parts is good for you, for maintainability and so on and so forth. But the consumer isn't interested into starting 70 applications in the morning. And because of this, you need to provide something around your 70 applications. For instance, a common shell that needs to get started and then that loads everything else. UI composition, of course, is something we have to deal with in the UI layer. With the other stuff you can deal in the backend, especially when it comes to interfaces, to distributed systems, or of course to distributed data. But with UI composition, we have to deal as Angular, as React, as Vue developers. And a first solution for UI composition is a solution that is more or less too easy to be true. It's about using hyperlinks. It is the easiest solution, but it has also a lot of drawbacks. One drawback is when you are following a hyperlink, then you are leaving your first single page application and you are entering another single page application. That means you are losing your state over there. And it also means that you have to do a pose back, something you don't want to do when it comes to single page applications. So it turns out this isn't necessarily the best solution, but it is a good fit for some kind of application suite. For instance, when it comes to a product suite like Office 365, it is a quite nice solution. When it comes to Office 365, you have one single page application per each Office 365 application. You have Word as a self-contained single page application, you have Excel, and so on and so forth. And in the top right corner, there is this sushi menu, and when you click it, then you get hyperlinks that lead you to other parts of your Office suite, to Excel, to Outlook, and so on and so forth. Or another example, let's talk about Google. Google itself is using this approach. Here you see Google Maps. And Google Maps is a self-contained single-page application. And one more time, you can use this sushi menu to get hyperlinks that point you to other parts of the Google Suite, to other single-page applications Google provides. The most important thing about this presentation can also be seen on this slide. When you don't remember anything, please remember this one point. It's very important for me. In Germany, there is a city called Steyer. I'm very proud of it. Okay, using hyperlinks is quite simple, but sometimes our users deserve something better. Sometimes our users want to have something like a shell where we can load micro apps in a dynamic way, where we can lazy load other micro apps. And when it comes to shell, we have different implementations options. I will start here with the most ugly options for implementing shells. What do you think? What is the most ugly option for implementing a shell application that can load other web applications?
To build another simple app.
Yeah, to build another simple app, yeah, and to use iframes. I don't know about you, but I get this strange feeling in the stomach when I hear the word iframe. But it turns out that iframes are not only bad. They also have some real advantages. One advantage of iframes is the isolation. An application in one iframe cannot harm another application within another iframe. They are completely isolated. And JavaScript error in this iframe cannot affect the other application in the other iframe. Fishy CSS in this iframe cannot destroy your layout in the other iframe. Those are the advantages. But of course, it also comes with a lot of disadvantages. For instance, you cannot overlap things over the borders of an iframe. You have to load a lot of pages, and you cannot SEO optimize your application. So I think you don't want to go with iframes for portals, for customer-facing applications. Perhaps it is okay for an intranet solution, but when it comes to customer-facing stuff, you need something else. Another approach you could go with is just bootstrapping several single-page applications within one index HTML. And then you need some overall logic that shows and hides those applications. That means you would perhaps load an AngularJS application into your index HTML, or you would load an Angular 6 application in your index HTML, or you could also load, in addition to that, a vanilla.js application into your index HTML. And then the overall logic decides which application is displayed at which point in time. Yeah, it's also a doable solution, but it's also not the prettiest one. The prettiest solution, when it comes to my opinion, is using web components. It is just a way to define framework-independent components that can be loaded into the browser in a dynamic way. And this leads us to the second part of this presentation. The second part is about web components. So let me know, who of you used web components before? Okay, that's great, because this is what this presentation is about. Web components are just components that are framework independent. That means you can write them with a huge variety of frameworks, and you can reuse them with a huge variety of frameworks. And they can also, as mentioned before, dynamically loaded into your browser. That means you can load them when you need them. So you can do something like lazy loading. And it is a standard, or to be more precise, it is an umbrella term for several standards. For this presentation, I've just picked two of those standards. Two of those standards I need when I want to write a micro application. Those are the official logos for the standards. The first standard is called custom elements, and the second standard is called shadow DOM. So let's talk about custom elements. When it comes to custom elements, you have a standardized way to write own HTML elements. For instance, an own date picker. This is not part of the HTML standard, but you can write your own by leveraging custom elements. And the best thing about this is that such a custom element behaves exactly like a built-in element. It behaves exactly like a table, like an input, like a form tag. It has properties and it has events. It also has a closing tag. And as mentioned before, you can write custom elements with one framework and you can consume it with another framework. That means it doesn't matter when your frameworks are changing, you can reuse your existing stuff with newer frameworks. And you can also polyfill it down to Internet Explorer 11. I'm sure some of you have to support Internet Explorer for some reason. No one understands, perhaps because it is coupled with some versions of Windows. And so you can also support those customers with those browsers. Some people are calling them evergreen browsers. It's a nice word for legacy. Evergreen, please keep this in mind. So there are some examples for writing own custom elements. For instance, you could write own widgets the HTML standard doesn't come with. For instance, a slider. You could write something that is use case specific, like a customer selector. Just imagine your application is about managing customers, then you could need a customer selector for the purpose of reusability. And you could put an own micro app into a custom element. That is not the typical use case, but hey, whole applications are also components. Just think about Angular. Think about all those other frameworks out there. In all those frameworks, the whole application is a component that consists of components that in turn, of course, consists of components. And so it is quite natural to also package a whole micro application by the means of a custom element. The other standard I'm talking here about is Shadow DOM. Shadow DOM allows you to isolate your CSS. And so the parent cannot influence the component's layout. The hosting application cannot interfere with the layout of your widget. This is very important because I think all of you know the situations where you are importing one CSS file for your framework and another CSS file for your widgets, and then those CSS files begin to battle with each other, and this results in really dirty markup and really dirty layouts. You don't want to have this, and to prevent such situations you can leverage the Shadow DOM. The Shadow DOM also prevents that the component can influence with the parent or with siblings. It just permits this. In addition to Shadow DOM, there is something that is also called Shed-D DOM. Shed-D DOM is an artificial word, and it means that you have to emulate Shadow DOM for all the browsers. And when you are doing so, then the parent can influence the component's layout. The outer thing, the hosting application, can influence the layout of your component. You cannot prevent this with the emulation because there is no way in CSS to do something like this. But when it comes to this emulation, you can at least guarantee that the component cannot influence the parent or the sibling. So it is not perfect, but I think you can arrange with this situation. You just have to take care about the CSS files you are importing into the parent. The good thing about ShadowDome is it also works with Internet Explorer 11 because you can emulate it. Okay, now the question arises, how can we use those web component standard, ShadowDome as well as custom elements, to write a shell that lazily loads micro apps? And one answer is you can use web components to write micro apps. Each and every micro app could be a web component of its own, a web component that can be loaded on demand, a web component that is isolated by the means of ShadowDome. I'm calling this macro architecture. And on the other side, you can have some shared widgets each and every application needs. And this also can be created by the means of web components. I'm calling this the microarchitecture. So now we have talked about the concepts, the principles of using web components, of using micro apps, of sharing widgets. Let's have a look at the implementation for this. In the implementation I've prepared for you, I'm using, of course, Angular, because I'm an Angular guy. I'm using ShadowDome, and I'm using custom elements. So when it comes to ShadowDome in Angular, I have a good message for you. ShadowDome is baked into Angular since version 2. Normally you are going with ShadDome. This is the default in Angular. And for this you just have to do nothing, or if you want to do it explicitly, you can set the encapsulation property to emulated. But as mentioned, you don't have to do this because emulated is the default value. When you are sure that you are only addressing browsers that are implementing ShadowDome, then you can set this property to native. Then you get the real ShadowDome with the full-blown isolation. And when you say, hey, I don't need that at all, I'm an expert, I know what I'm doing, then you can turn it off. Just switch to none on your component basis. You see a big advantage of this here. You can decide upon this on a component basis, not just for the whole application, you can decide component-wise. When it comes to custom elements, we also have a solution. It is around since 7 weeks. It arrived with Angular 6. And it wraps an Angular component so that the Angular component looks like an ordinary web component to the browser. The solution is called Angular Elements. And those Angular component is then exposed to the browser as a traditional custom element. So what does it take to use Angular elements? To be honest, it doesn't take much. First of all, you need your component, perhaps a micro application component, and you have to put it into your entry component section. Normally you would go with your bootstrap component section, but here when it comes to Angular elements, just use the entry components. And after this you need some lines of code that wraps your Angular component so that it looks like a custom element. And for this here I'm using the ng2bootstrap method within my module. This method is automatically called when the application starts up. And within this method I'm using this new function. It is called create custom element. Create custom element gets an Angular component. Here it is my micro app component, and it returns a custom element. In addition to that, you should pass your current injector, This makes sure that your component is connected to the dependency injection mechanism of your application. The next line has nothing to do with Angular. The line with custom elements defined is part of the custom element standard. It just tells the browser that there is a new custom element the browser shall take care about. And this custom element here is my micro app element. After this line of code, I can use and tag with the name micro app within my application, and the browser will make sure to render this element into this tag. This could look like this. I just need to reference my bundle, and then I need to create an element for my custom component for my micro app. And of course, every one of us can imagine that with some DOM magic, we can do this in a dynamic way. Every one of you could create some JavaScript code that is dynamically inserting this script tag, and every one of you could create some JavaScript code that is dynamically inserting the micro app element. And this is the key to lazy loading, to loading everything on demand. Okay, let's come to a demonstration for this. Here I have a simple application. It is Angular based, of course, and this application allows me to search for flights and to search for passengers, and for this I'm clicking to flights or to passengers. And what happens here is I'm loading a completely different application into my single page app, into my Angular application. To show you the borders of everything, I'm using those dashed colored borders. Here I have a red micro application, and here I have a blue one. So I can switch back and forth, and I can also use routing within my micro apps. The best thing about custom elements, the best thing about web components is we can also mix and match our components. For instance, here I am using some component from the red client within the borders of the blue client. And the best thing here is each and every component can be written with an own client-side framework. For instance with Angular, for instance with Vanilla.js, for instance with something else. Another thing that's very nice here is that you can develop your micro apps in an independent way. As you see here, my red client can also be executed as a standalone solution. So you can develop it independently, you can test it independently, and you can deploy it independently. When you are done, you can just copy it up to the web server, and the shell application will just load the newest version on demand when it needs it. Of course, all those things are quite simple when it comes to traditional server-side applications, but when it comes to client-side applications, you need all these tricks and those techniques like web components, custom elements, and so on and so forth. So if you like this presentation, I have a blog where I've written some articles about this topic, and you can find all these articles on Software Architect AD. I'm writing in English, but the domain is currently a German one, or let's say an Austrian one, Software Architect AD. Okay, let's come to a conclusion. When it comes to micro app, we can have a separate deployment. That means we don't have blocking tasks, we don't have to wait until our colleagues have done. We have less coordination, we just need to have coordination within our team, but we don't have coordination between teams, and this prevents a lot of political discussions and so on. And we can also mix and match client-side technologies, and as mentioned before, this is important when you have to maintain a business application for a long time. When it comes to technologies, we have something like Shadow DOM and Angular elements in Angular. These are the building blocks of my solution. And we have something like the macro level and the micro level. Okay, here I have the macro level and a second macro level. But to be honest, we have a macro level and a micro level. The macro level is about loading whole micro apps into a shell. And the micro level is about organizing these micro apps. For instance, about sharing common widgets between those applications. Here you have my contact data. Feel free to reach out using email, using Twitter, or also feel free to ask some questions now. So thanks for coming and have a nice day.
Big applause. Thank you. Thank you, Manfred. Does anyone has a question about this topic? Please raise your hand. No one, maybe, oh, one, okay.
Thank you. Just would like to ask, how would you share data between those components? Like, let's say we have one application, we have some data loaded, let's say in the main container, and then how would you share the data and make a transition and so on?
Yeah, I think there are two possibilities for sharing data. One possibility is using RESTful endpoints or something like GraphQL. That means a server-side solution. And in this case, you can just talk with your service of the neighborhoods, with the service of the other micro application. And the other approach is about redundant data. In this case, the micro apps, or let's say the backends of the micro apps, the microservices, will send out data to them to each other. For instance, let's say something has booked an order. In this case, you need this information in your order system, but you need it also in your supply system. And for instance, you could also need it for your recommender system, that a specific person purchased this or that good. And so you can just send out some informations by the means of REST or by service bus, by messaging and so on. In this case, you have redundant data.
Another question? One big applause again for Manfred, please.
Thank you.
Thank you, Manfred, for